Okay, so now that you've seen an introduction to the polar world and you've also refreshed your memory on conics and their parent functions in rectangular form, we're going to let these two worlds come together and show you that you can do a ellipse, hyperbola, parabola, and a circle in polar mode. So just like everything else, these are going to have a parent function. Now let me write the parent function, and then before you freak out, I'll explain what all these parts are, okay? 1 plus or minus e. Okay, so I'm just going to, for the second parent function, recopy what I have for the first. The only difference being sine or cosine, and you can probably already guess what the difference between sine and cosine does, because it's the same with any other parent graph. These are just going to be your orientation, right? Sine, you need to think y, so these will be vertical. Cosine, think x, so they'll be horizontal shapes. And the p is the same as what you were doing with rectangular conics, so that would be your focal distance, okay? Your focus, think of it that way. And then E is the new thing. So what is this E? Okay, well E stands for eccentricity. Eccentricity. And basically eccentricity is just a constant in math that compares a ratio. What it's doing is on a conic in polar mode, it's looking at the ratio between a shape's focus and the directrix and something called a locus point. And this eccentricity is looking at that ratio as you travel around the shape to see what's happening. So let me give you just one example. If I can real quick. Okay, so let's say we have x and y axis. Let's say we've got like a parabola over here. Okay, so with a parabola, you're going to have your focus, and remember the directrix is the same exact distance away, okay? Now, what we're going to do is take a look at a random point that's on this parabola, okay? And this is assuming I've drawn my parabola well, but I probably haven't. Okay, let me clean that up just a little bit. Okay, so a random point on this parabola, so let's say like maybe right here. Okay, so if we were to look at the distance from this point to both our focus and our directrix, if I drew a perfect parabola, that distance should be the same. So in other words, the ratio of this side divided by this side should be 1. And that's important because that's how we'll know what function we're looking at above. So if the E up here is 1, it will always be a parabola. And the other shapes, what happens is as you start stretching this hyperbola, maybe forming an ellipse from it, forming a hyperbola from it, what's going to happen is that ratio is going to change. So let's look at the generic rules first for eccentricity. So if the eccentricity is 0, you will have a perfect circle, okay? We already said this one. If the E is 1, it will be parabola. If E is, let me write it like this. If E is between 0 and 1, you will have an ellipse. And if the E is greater than 1, you will have a hyperbola. So what we're going to practice is somebody, maybe gives us a parent function and in polar mode, and we should be able to tell what the shape is going to be just by taking these rules here and these two parent functions here and sort of comparing them. Okay, so let me give you your first example. Okay, so let's suppose we're given something like this. And we could be asked all sorts of stuff. We could be asked to identify the shape, find the eccentricity, find the focus, all kinds of stuff. I'm going to have you guys, if you would, hit pause and go ahead and look at this graph on your calculator just so you know sort of what it looks like. And then that way when we do this with algebra, you'll believe me. Okay, so take a second, and then after you look at it, come back to the video. Okay, so what you should notice, I think, is that this is going to be an ellipse, and it should be a horizontal ellipse. Horizontal, I know because of the cosine that's right there, and ellipse because I know that my eccentricity is between 0 and 1. And you might be thinking, well, how did you know that? Because this right here looks nothing like this, but it actually looks a lot like this. This would be the parent that we're trying to get it to look like if I look above at the parent functions. And so what I'm going to do is just sort of take this equation and this equation and try to make them look the same. So don't just assume right off the bat that the eccentricity is 2, okay? Because the problem is, or the key, I guess I should say, the key is this number here. We need this 3 to be a 1. So how am I going to turn a 3 into a 1? Well, I'm going to divide it by itself. I'm going to take that 3 and I'm going to factor it out, and that's going to give me a 1 right here. If I'm factoring by 3, this will become a 2/3, right? Because I'm just dividing it out. And now I can reduce this, and it will look like this. So R is, let's see, that would be a 5 over blah, 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 blah. Okay, just recopying. All right. So there it is. I've made this parent look as close to this as I possibly could, but now that that's a 1, I know for sure that the eccentricity is 2/3. And since it's 2/3, just like this says, it's between 0 and 1, so it's an ellipse. I also know that if somebody wanted me to find the focal distance, I could, okay? The focal distance is P, and this just becomes an algebra equation, so try not to overcomplicate this. If you look up here, the numerator is supposed to be EP, right? But the numerator equals 5, so I'm just setting up a comparison equation here. EP has to equal 5 based on the parent and what I reduced to. And then I know that my E is 2/3. So I'm just going to do, like I said, usually do a little algebra. If this is 2/3, then I can totally find the P, the focal distance. So what do? I'm going to multiply by 3/2, and I'm going to get 15/2. All right, so there you have it, kiddos. Just being able to identify the polar graph based on what you see in the equation above. You'll have a few practice problems on a homework where you're doing basically the same thing that I'm doing here. So remember the goal, always try to make this the 1, and then go from there. Also, I would definitely graph every single one of these. I know on a quiz or test you might not have a calculator to graph them, okay? But for now, while you're learning, it's really important to try to make the connection between, you know, a rectangular conic and then in the polar world, and then being able to identify. That'll be a big theme. So hopefully either in polar form or in rectangular form, no matter what we give you guys, you'll be able to take something like this and know what you're looking at. So I just switched back to rectangular mode just to keep you on your toes real fast. But you know, we did this. If we took an equation like this, we could also identify the conic. We don't have to find the E. We don't have to make it look like the parent function. We just look for things like there's a squared on each term. They have different dilations in the front, and there's a minus between them. This is going to be a hyperbola. Same idea here. We at least know what shape we're headed into, and then we can do a little bit of work if we need to. So hopefully that gives you enough to get going on your review, and we will test next time. Thank you.